Zero Knowledge Proof workshop at Berkeley. I did this workshop today, and I want to talk about this, also explain why I'm doing this. Don't forget, the purpose of this podcast is to give people a sense of what it feels like to run a hedge fund, and visiting a very technical workshop at University of Berkeley, I think really encompasses what we're all about at Orange Capital Partners. This is a Not Even Wrong podcast. It's October 30th, 2022. This is Krim Delco. It's a Sunday. There's no update for the year. We're down 44.6%. The market's down 16.2%. We're underperforming by 28.4%. The visit today at Berkeley was about zero knowledge proofs. So zero knowledge proofs are, let me try to not too technically explain what I mean with that. So there is a big development in the blockchain/crypto world, and that is, how can we make sure that a certain message is true, and how can we maintain privacy, and how can we do all of this without using an enormous amount of compute resources? So this, I would say, this is sort of the design space within which we're living. And the solution right now, as we speak, is called zero knowledge proof. I mean, these things are changing sometimes, buzzwords here and there, but let's just call it ZKP, so zero knowledge proof. What it means is that we have an internet of identity, or a blockchain of identity. The word blockchain is still being used in many contexts, but one of the big takeaways from this conference for me is that I think we will at some point replace the word internet with the word blockchain. In other words, we'll have something called the blockchain, which will encompass an internet of identity, or a network which will exchange transactions between its nodes or actors, or actually nodes, let's call it nodes, and those transactions will be verified implicitly. So it's not like we need a third-party verification, some sort of super authority that makes sure the blockchain is always true. It's implicit in the blockchain itself. It's implicit in the contracts, in the network, not even in the contracts. The contracts are being executed, millions and millions of contracts per second, and all of them implicitly have a validation with it. So in other words, we have a blockchain, or an internet of identity, that I call blockchain. This is one of the big takeaways for me from this conference, is that we will be morphing the internet into the blockchain, and the blockchain is a network of transactions that are implicitly verified. So this is the way I see it. Now, the workshop itself was very well attended, I would say, about 500 people, researchers, entrepreneurs, very good energy. And here's another big takeaway. I just did a workshop about machine learning and AI about 2 weeks ago, and I think this one, I feel, had a lot more energy, a lot more entrepreneurs. There's a lot more things going on. And I think this is good testament for where it's at right now. Even the organizers, one lady at University of Berkeley, professor of computer science, I will put the names in the show notes, doesn't matter. She was the organizer, very nice lady, by the way. And she herself is actually a machine learning AI researcher, but she morphed into doing work on distributed networks, and is by nature now in sort of the blockchain space. So there's just one big claim that I have, which is we're going to start using the word blockchain, and we're going to replace the word internet with blockchain. And the difference is, the internet is a network of messages, and the blockchain is a network of identity. So it's a network of nodes that continuously are exchanging transactions, and those transactions are validated. I think this is the main takeaway. And I think what's really interesting here is of course, a couple of things. First, I mean, there's a technical problem to be solved, which is this zero knowledge proof. The zero knowledge proof is the idea that you can prove that the message is true without knowing anything about the message. This is in general what zero knowledge proof means. You can Wikipedia it, you can Google it, you can do, right? I mean, there's a lot of course, technical know-how that's being developed. I think important for me, first, it's a very growing research area. Dan Bonnet was there, one of the leading cryptography researchers in the world, and he's very involved. So that already shows that this is an interesting area. And I think the area is interesting because we're building a new internet. Again, we're going to replace the word internet with blockchain at some point. And let me try to explain why we're so excited about this. I think we've said many times on this podcast, the purpose of Orange Capital Partners is to generate wealth by investing in fundamental new concepts and engineering practices. Now, this is absolutely along those lines because it's a fundamentally new concept, and also it requires lots of new engineering practices. One quick way, one sort of back of the envelope type way to assess if something is a fundamental new concept is just when you see that a lot of traditional university offices are overlapping. This is always a good way to assess. So in other words, you can have let's say research in database technology, right? Certainly important, but it's going to be done within one department of the university. You can have research in applied econometrics, which will be done within the economics department, in the econometrics department of the economics department. So it's pretty clear where it's happening, and the reason why that is, on the one hand, the good thing and the bad thing. The good thing is, of course, there's going to be a lot of expertise thrown at it. You will have a lot of experienced people talking about something and citing papers and papers that have been written about this, etc., etc. The bad thing is, because of all of this, you can bet that it's going to be very hard to really make leaps here. Wealth generation happens when university departments overlap. When all of a sudden you have mathematics, you have complexity theory, which is a part of mathematics, but then you have cryptography, which is overlapping mathematics and computer science. Then you have computer science, and then you have, even within computer science, even electrical engineering. So all these areas are overlapping. Let me try to elaborate. Let me parse that a little bit more. So we have, of course, the area of cryptography in general, and zero knowledge proofs is first and foremost a mathematics problem. Cyril Micali, a person I interviewed maybe 2 or 3 years ago, a researcher from MIT, he himself got a couple of medals and some sort of mathematical version of a Nobel Prize for, amongst other things, co-developing zero-knowledge proofs. So that started in the mathematics field. Now it's morphing into more complexity theory / different branches of mathematics, because the zero-knowledge proofs themselves have to be adjusted to the actual problems they're trying to solve. And now we're stepping into computer science. Well, the actual problems that are being solved are, for example, problems such as solving a transaction, or proving a transaction, proving the content of a transaction, but make this so you don't reveal the identity of the person that is being proven, or the prover, which is being validated by the validator. The prover doesn't want to reveal their identity. So those are problems that are comp sci problems, in a sense that now we're looking at things like, for example, okay, what kind of algorithm are we going to use to do this? And what is the O? In other words, how many is this linear in the amount of data that is being processed, or is it exponential? Is the algorithm going to be logarithmic? Because what we want, of course, is something that is at least linear, if not less linear, logarithmic, because we don't want to have explosion in compute power and resources and costs. So this is a comp sci problem. Now, it's getting into the hardware side of things, where now we have to solve for two problems on the hardware side. One is, again, we want to optimize the kind of workflows that are necessary to do a zero-knowledge proof. So we have certain algorithms and certain actual programs that are being used to solve these things. But then we need to solve for robustness. In other words, because we're dealing with computer security and cryptography, we have to make sure that these circuits that are executing those proofs are themselves bulletproof. That's the key. So this is a sort of a recursion problem. Is the thing that you're using to prove stuff safe? Is it proven that that thing is provable? Is the prover safe? Is the prover proven to be safe? So you see where this is going. It's a pretty complex thing. It's a sort of convoluted problem, because now we have to make sure that the circuit that is being used is to prove something is provably correct. And everything, when it comes to cryptography and particularly blockchain technology, of course, it is all about how can we make this thing decentralized and trustless. This is the key. It's easy to prove stuff if you have a central authority that is paid to do it. The CIA or the US government and so on and so forth. I mean, their job is to make sure that whatever happens within their network and their sort of realm is true, right? I mean, at least that's their job. Might not always be the case. But we know that if the US government says something, that it's typically, we can trust them, right? We know that if the New York Times says something, we can trust them, and so on and so forth. So we know that's the old world, right? The new world is decentralized, trustless. So this is a network that implicitly verifies everything. If I get an email from you without anybody centrally validating you and validating me and validating the message, I am certain that the email is from you and that the message is correct. The Byzantine generals problem, which is the big deal that Satoshi Nakamoto solved in his white paper when Bitcoin started, and I think that was the beginning of this new area of decentralized compute, or call it decentralized identity compute, which I'm going to now summarize just with the word blockchain. So blockchain gets its huge kick with the white paper. And there is actually a new podcast that I saw on YouTube. So I don't know if it's on podcast or just YouTube. It doesn't matter. Again, the names don't matter. The company's Blockstream, and the founder of Blockstream, he just had in this first episode of their podcast, he talks about sort of the history of Bitcoin and the history of blockchain and the history of decentralized decision-making and solving of the Byzantine generals problem. So this is all correlated, right? This whole area, this whole explosion of research, all I think starts with the Bitcoin network, and then morphs into Ethereum and all the other coins and all the other blockchains that are out there. But we can still generalize the problem into just the blockchain problem. If we're having the underlying blockchain, if the name is Bitcoin or Ethereum, and if the details are X, Y, or Z, that's a whole different conversation. And actually, in this particular conference that I attended today, even the actual underlying blockchains were not discussed as much. Most of the research papers that were presented were based on Ethereum, and Ethereum seems to be taking sort of a big leap forward when it comes to the application of lots of problems and solutions of lots of real-world problems. But that's a conversation for another podcast, which is, by the way, a very important conversation. Where should we invest? What should we follow? Which conference should we go to? These are all big questions that we have to answer at Orange Capital Partners all the time. Don't forget, the purpose of this podcast series is to give people a sense of what it feels like to run a hedge fund. So knowing what to research on and understanding what questions to ask and where to go and who to talk to is a lot of what we do at Orange Capital Partners. Now, to be fair, today I was pretty intimidated, okay? I actually didn't even ask a question. I barely spoke to people. It was pretty intimidating because the problem of zero-knowledge proofs is a very technical, mathematical problem that I'm not very versatile in, and I really don't want to go to these conferences and waste people's time. So to some extent, I have a little bit of an identity problem myself, in a sense that, am I really qualified to do this? Blah, blah, blah. It doesn't matter. I think we're all always qualified. There's no such thing as a stupid question and all of that. And nevertheless, the people are pretty intimidating. So I have to work on this. And I think my next conference will be a lot more, my next conference within the blockchain/zero knowledge proof space will be a lot more confident on my side, and I'll be able to talk to people. But anyway, what are the big takeaways here? Again, we have the internet's morphing into the internet of identity, which I'm going to call the blockchain. The blockchain is a way to validate transactions. The blockchain is, think of the internet as defined as transactions, and the transactions are validated implicitly in the network. And now the big questions are, okay, where are we going to do this? Are we going to do this in layer 1 or layer 2? And there are some attempts, particularly by Ethereum with the big merge, which is they try to do the proof of stake thing, which kind of validates everything in layer 1 at a much faster clip, lower. Again, the design space is such that we want to be able to have subtle proofs or snarks, succinct, what is the N standing for? Non-interactive arguments of knowledge, SNARK. Succinct, non-interactive arguments of knowledge. In other words, we want to have short and spicy proofs that something is true without interacting with the actual prover or the person that needs to be proven right. And how can we do this? Again, zero knowledge proofs are the solution. There are certain, I've spoken with one participant in the conference. He told me that he thinks that what's called plonks, which is sort of a technological solution to the ZKP problem, that's kind of a local optimum right now, and that there are better ways to do it, but we're all stuck there. So I think that's fine. That's exactly how technology evolves in Silicon Valley in particular. We have these local optima. We have, let's say, Mosaic browser, local optimum, and then we have Safari, Internet Explorer, Google Chrome, lots of things, developments, and you know, the browsers, they evolve until they reach a certain plateau, and then the innovation on the browser side deteriorates and other things pick up, the App Store, the iPhone, blah, blah, blah. So the same thing here. I think we're going to see a lot of local optima and then some sort of plateauing of innovation, and then we're going to have a continuation of innovation in other areas of the branch. So where we stand right now is we're still in early days of developing the blockchain. So we've said many times on this podcast that we are, in a sense, Bitcoin maximalists when it comes to the actual use case for blockchain technology, which today, as we speak, is literally money. It's money, it's store of value, it's digital gold, it's a competition to the US dollar. That's where Bitcoin has succeeded the most. And I would say if I had to take the value out of the blockchain technology today in practice, is probably 99% the Bitcoin currency. That doesn't mean that all the other things, the Ethereums of this world, the Algorand's of this world, that they're useless and a waste of time. It's just that their use cases, their applications, and all of that stuff that comes with it are still in early days. And I think this Zero Knowledge Proof workshop was a good reminder that there's a lot of work to be done and a lot of interesting work that can be done in that area towards a blockchain where implicitly everybody who participates continuously engages in transactions, and those transactions have an implicit algorithm attached to them that makes sure that identity is proven and that you can continue doing business or doing transactions. In other words, excuse me, I mean, it's not really business, it's transaction. So if I send an email to somebody, just call that a transaction. If I buy an NFT and all that stuff, everything is transactions. Sometimes money is involved, sometimes not. But the key is that every node in the internet transacts and implicitly is validated. Now this opens up branches. You know, we've said, for example, the interesting thing about Twitter could be for Elon Musk to start going into that direction. And I said today to my colleagues that I hope Elon Musk should have been in this conference. I believe that the energy that I felt was very it was addictive. I felt energized. I felt interested. I felt like there's something going on. I want to be part of this. I didn't feel like that with the machine learning side of things. Not that machine learning or AI is less interesting. Actually, it's a lot more interesting, but it's a little more mature. And the applications are bigger, and the money is bigger, and there's less startups and all of that stuff. Here, it's so small. You have almost everybody there was some sort of grad student / postgrad / PhD / professor, but they also were entrepreneurs. Everybody had a business in some sort of area within the ZKB because it's software. It's relatively low cost, low capital intensity, high reward, lots of iteration, all of these things that have made Silicon Valley big in the last 20 years. So let me talk a little bit about the actual specific problems that need to be solved. One is, again, I said, if we take the university departments as a good sort of, how should I say, as a blueprint for how to think about this problem, right? So we have mathematics, so we have the idea of, okay, how do we actually do zero knowledge proofs? And it has to do with, the way it actually works in practice is that you represent a certain problem as a circuit. And the representation of the circuit is such that you define, let's say, node A in let's say circuit C, right? Node 1 in circuit C is related to node 2 in circuit C by a certain mathematical function, and then node 3, node 4, everybody's connected in a certain way with each other. And the actual zero knowledge proof technology is based on the verifier making sure that the prover, so the person that is actually claiming that, let's say, message M is correct, so the verifier asks certain random questions to the prover, and by answering those questions, the verifier can then reveal that the message is correct without revealing the actual message. Let's leave it at that. I don't want to go deeper first, because I think it would explode this particular episode, but also actually my knowledge is not that deep for me to be able to explain it in a more natural way, that it's more intuitive, because it's quite frankly not even that intuitive to me right now. But I'll take it for granted that this is something that is out there. People are using it. It's actually being used in blockchain technology today. And now let's move on to the next problem, which is, okay, how can we do this in a more computationally efficient way? Because what we want is succinct. The snark thing has the word succinct. So the proof has to be succinct and the verification has to be succinct. So both of them. So that means that you can, for example, have a message, and when we talk message, of course, it could be an email, but it could also be millions and billions of transactions that need to be verified in a blockchain. This is how blockchain works. You have to verify, let's say, that the next block, which contains all the other transactions that have been happening since Genesis. And things like that need to be done in a computationally efficient way. So how can we solve that? There are certain solutions being offered. There's businesses. And like somebody said in the conference very well, actually, almost every layer of this whole stack has its own startup scene. And that's great. That's another huge indication for an interesting area. When you have a certain, let's say, sector, or call it stack. We spoke about stack thinking just recently on this podcast. So we like to see the world in terms of a stack. And when we have certain layers of the stack, so here it's, let's say, the stack is mathematics, then we have comp sci, so what kind of algorithms can we actually implement to solve certain mathematical problems, and then we have also the hardware side. So now we're going deep into things like ISA, and there was actually a group that presented today that was offering solutions to this particular ZK problem from a risk perspective, so risk 5 perspective to be precise. And of course, this being Berkeley, I'm not surprised that we had an approach that is using a new ISA which was developed at Berkeley to solve this problem. So I think, to summarize, I don't want to go there. I mean, I could go on and on and on, but I think, again, the key here is that we are at the cusp of a new area where the word internet is being replaced by blockchain, and the blockchain is the internet of identity implicitly in the network, developed by something called zero knowledge proofs. It could be something else, but right now that is sort of the front runner for technological solution, for the technological solution to actually implement an internet of identity. And what's great about this, again, is the main thing is that many different departments of the academic world are intermingled, which means lots of there's a Cambrian explosion of innovation, of ideas, of technology. And for us in Orange Capital Partners, that means there's an opportunity to deploy capital into something that can generate wealth by developing new concepts and engineering practices and solving all the big problems that are associated with this, and of course also having a massive positive impact on the world by solving those problems.